and welcome to another math tutorial. In this video, we'll be discussing a geometry question, and this time it's about triangles. So let's start. Let's read the question. It says, consider a triangle ABC such that the angle ABD is 20 degrees and C is a point on BD such that AB equals AC and CD equals CA. Then the measure of angle ABC is. All right, so we set out to find this beautiful, colorful angle ABC, and we're going to do that with the help of this triangle ADC. All right, so let's do it. And before we begin, we make use of a certain property from the triangle isosceles. What does it say? The property of an isosceles triangle is that two adjoining sides are always equal and the base angles in between them are always the same. And we're going to make use of this. Along with that, there's another one, very common and popular rule in triangles, which says that all the angles, the internal angles of a triangle, sum up to 180 degrees. Let's use these two concepts and put them in triangle ADC. So let's get this triangle out. Okay? This is your triangle A, D, and C. Just a second. Okay, A, D, and C. And we know that DC or CD is equal to CA. That means this is equal to this. And hence it's an isosceles triangle because two adjoining sides are equal. So that means that their base angles are also going to be equal. Let me invert it. Let me rotate it and show it to you like this, like so. So I'm going to put the C on top, like I just rotated the triangle 90 degrees towards the left. So C goes on top, A comes to the left, and D comes here. Now, just drawing the same thing, CA equals CD. All right, this looks exactly like our triangle over here. All right, and then the base angles are going to be equal. That means angle C, A, and D is going to be equal to angle C, D, and A, right? These are the base angles. What next? You know that angle CDA, okay? CDA is 20 degrees. CDA, this is 20 degrees. So this automatically becomes 20 degrees. So what's this? What is angle CAD? My bad. C, not exactly C, but ACD. See, the mistake that happened here is that you always keep the vertex in the center when you name an angle. Let's say if you want to find this angle. So how would you name it? You would say angle CAB, or you would say angle BAC. But A always stays in the center because A is the vertex, okay? This pointed thing. So remember the nomenclature in case if you don't know about it. Now next. So we were finding A, C, and D. Now you know two angles of a triangle and you want to find the third one. So we make use of this second thing here. That's the angle sum property. So you know it's anyways going to be added to 180 degrees. That means you have 20 degrees from triangle angle CAD and then 20 degrees from angle CDA. And then you don't know what this third angle is. Let it be X. Solve the equation and you'll get 180 minus 40. That's 140 degrees. That means you got which angle? You got angle A, C in the center, and D. You got ACD. You got ACD. You got this angle. Okay, this one right here. I'm going to write out here. You got it. It's 140 degrees. There's another thing to understand here, particularly when you find this angle, when you're finding this angle, is that there's a concept that's known as linear pair. And linear means straight. So straight pair, what does that mean? If you have a line, and then there's an angle like this. So this angle, which is like right next to it, or more popularly known as that joining angle, these two are going to add up to 180 degrees because, see, what exactly is it? It's 180 degrees. So these two should add up to 180. All right, let me clear up some space. So we got this as 140. We know these two angles are going to be a linear pair. So this angle over here, this portion, is nothing but 180 minus 40, which is 40 degrees. Okay? So let's take this bigger triangle out and do the same thing that we did with the first triangle, triangle A, C, and D. All right? We're going to take the bigger triangle out from here. We're taking this out. So This is your triangle. Wow, that's a neat triangle. This is 40 degrees, we just found out. And yes, this is another isosceles triangle. Triangle A, C, and B here. B, because CA and, AC and AB are equal. So you have two equal adjoining sides, and hence their base angles are going to be same. So this is again 40 degrees. And mind you, what were we finding? We were finding angle ABC, this colorful bit here. And you got it. So angle A, B, and C equals 40 degrees. Let's recap a few rules that we discussed. The first one being that an isosceles triangle has this property where its two adjoining sides are equal, and then the base angle in between them are also equal. And then the second property is the general property for any triangle with three sides where you have the internal angles adding up to 180 degrees. And the third logic that we applied today was that of a linear pair where you have two angles, and if they are lying on a straight line, then they add up to 180 degrees.